All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's me, Lady Ada, the engineer, with me, Mr. Lady Ada on camera control. Next couple weeks, we're going to have some guest fruiters hosting, but for now, you still got us, the OGs. We're here for the next 25 minutes. We're going to check in with people from around the maker community, Ada fruiters, and friends of the fruit and more. See what they're up to. What are they 3D printing, coding, robotically drawing, and more. Everybody's welcome. Come by Discord, where the link is in the chat, and all you use a webcam. Come to StreamYard, and we'll check you out. We're here every week.
All right, first up, Lenore, Windell, you have an announcement. Welcome back to the Show and Tell, by the way. I think you've been in person and also virtually before.
It's been a while since we've been on Show and Tell, so it's awesome to be back. Thank you for having us.
Like 7 or 8 years, maybe. Oh my God.
You
mean last week?
Yeah, the last 4 years don't count. Leap years. So I got the announcement, and there's a new bot in the Bantam family, right?
That is totally true. The NextDraw pen plotter was just announced on Monday, and we've got one right here.
Got one right here, kind of whirring behind us.
Oh, it's fast.
It's really fast, yeah. So
all right. So for the folks playing at home, what's a pen plotter? What's this artbot, and what does this have to do with the recent Evil Mad Scientist Bantam merger?
So a pen plotter is a machine that takes a pen and draws it around a page under robotic control. Usually start with a drawing on the computer and tell the machine what to do. And we love these machines because they make art and can do handwriting-like things. And we've been principally making pen plotters since 2010. So
we've been doing pen plotter projects for a lot longer than that.
Yeah.
Dating back to the early days of Maker Faire and so on, we were playing with pen plotters, not just using them for making art, but also for making things like 3D printers. They're some of our favorite hardware. The old pen plotters had fantastic components to harvest that we used to play with.
Yeah, we built the Candy Fab 3D sugar printer in 2007 out of old HP pen plotters.
Oh, cool. But those were like really expensive. They're like $1,000. I don't even know if they're made anymore, but this is like a bargain at half the price.
Yeah.
Buy this now, or?
If we had the budget to put into a plotter of what they used to sell those plotters for in today's dollars, it would be astronomical, and we'd make some even more amazing things. But
it was like buying a car back then to get some of the best plotters. But ours are relatively affordable, but they're still high quality. And these ones are faster, stronger, better.
Is the art behind you guys made with that pen plotter? Or looks like pen art?
We are actually in the gallery here at Bantam Tools right now, and we're in a room completely filled with pen plotter art from a number of decades and a number of artists. There are some things in here that were made with our machines, but not any made with a NextDraw yet.
Well, other than what we've got here that the plotters are doing right now.
Okay.
All right. So a couple questions. So recently, Evil Mad Scientist Bantam merged together. So is this the first bot that's being sold through Bantam? Is this one entity?
Yep, that's right. We are. We have, after running Evil Mad Scientist for 10 years.
17 years.
It's more than 10 years.
But the same as later. Yeah, those years will get you.
17 plus years, something like that, for a long time.
2007. We have merged with Bantam Tools, and we've joined forces to make amazing art robots, and we have just moved ourselves out here to Peekskill, New York in the lower Hudson Valley, and this is our first machine that is made here, so we're very excited about it.
Yeah, we wrote about this. We saw you at the museum when there was an exhibit with some pen bots, and I said it there, and I'll say it here. Being able to have a partner that can handle some of the logistics, the operations, the shipping, and all that. I was excited because okay, great, you can do the things that you want to do, which are getting more art bots and more into the world. Does this come as a kit? Is there any assembly? What do they need to do if they purchase this?
These come fully assembled, ready to plot, except for the big one, which is partly disassembled because it's really big.
Yeah.
And so you have to put the two parts together to get it running. But for the most part, they come ready to use.
Okay,
The-
right.
These guys have an arm that sticks out from the other one. So if you want to ship one in a box, it's this giant X-shaped thing.
Yeah.
And so for the largest model, we do all the tests and everything. Oh, Lenore's picking up the giant one. Don't hurt yourself. So watch
I'll
that
zoom
right
in.
side.
There we go. Here we are.
So this is the big one. And in order to fit this in a box, we take the Y arm off and set it next to the other one. And so this one is designed with a special main carriage that is designed that it can be disassembled into two parts and then reassembled without losing precision. We're getting an assistant to help carry this.
Thank you, assistant.
Thank you. That's
Give
Zach,
assistance
one of
now.
our new folks here.
All right, and what's the web pricing? If they order it online.
So there are 3 different models. The small one is letter size. This one is $6.99. Whoops. Something.
$6.99 to $16.99. Is that right?
Yes. 700, 1100, and 1700 for the different models.
Good tiers.
All right, great.
Yeah.
Small, medium, large.
Yep.
That's all.
Okay.
All right. Well, outstanding. You have an open invite. Maybe you could come back and show off some of the artwork and some of the things that you start to make with these. Invite customers because I know these type of things have a community of people who share. Come by on Show and Tell.
We'd love to. And
All right.
anytime we can answer any questions for you and your folks and your community and tell you what we're doing out here, we'd always love to.
Yeah.
All right. Drop the links for the bots in the chat in Discord if you can. And thanks for coming by. We'll see you real soon. And it was really good to see you. And welcome to New York once again.
Thank you.
Great to see you.
Yeah. All righty. That was a pleasant surprise. All right. Let's go to some Adafruit folks, and then we'll go around to some folks who came in. Scott, what you got going on?
Hey, how's it going? I've been working on BLE on the ESP. So let me share my screen here. Hopefully it works okay. Wayland has been a little bit of a rocky start in terms of sharing screens. So I've got my 3 windows set up here. One of them is not really useful. I'm running on the ESP32C6. And unfortunately, my demo crashed. So what I'm going to do is I'm just going to hit the reset button. So I'll just make that. You don't need to see the other ones. So I hit the reset button. Hopefully it'll start up again. Oh, I got a blink. But I'm not seeing any scrolling. I wonder why that is. Sometimes I have to restart TO. All right, so I've restarted TO. What I'm going to do is it should be doing a BLE demo.
Mm-hmm.
So I'm going to use the Nordic NRF Connect and just see if I can see it, which I can. So now I'm connected. And I can say, hello, show and tell. And it shows up there. So I typed it in on my phone, which you couldn't see. And it got all the way down to my ESP device. So this is via packet buffer, which is often used for BLE, HAD, and MIDI, I think is what we use packet buffer for. And then it also echoed it back to my phone, but you couldn't see it. So that's on the ESP32C6, hosting a BLE server, which we couldn't do before. So this will match NRF better.
That's like a Bluetooth keyboard or a mouse or like a heart monitor or serial, SPP-ish device. So you basically mimic a Bluetooth, I want to say peripheral. I know the names mean certain things.
The peripherals, the names.
But
yes, a device.
Not the central where you're like a phone or a computer.
Right, you're being more like a device rather than talking to a device.
Right.
You're actually being the device generally. Yeah, it's exciting. A lot of that is going to depend on some additional functionality, but this is a big hurdle that has been in our way for quite a while.
Okay.
So,
and it's possible because what they added dynamic
servers. Yeah, so the ability to like add a server once a connection is already going. a challenge we have with a lot of vendor SDKs and BLE stuff is like they expect you to know up front what all of the servers that you're going to have are, and then start up. But because CircuitPython is so dynamic, we actually start BLE before user code or as user code runs, because we have this BLE workflow thing. So we need to be able to add services kind of as we want to from user code, even if connections are already established.
Okay.
So the ESP IDF added that in 5.1.2, and so we're taking advantage of that new functionality.
Yay! All right. Well, this is great. All espresso chips, hopefully,
that have BLE support.
That have BLE,
not
the
S2,
but the S3, the classic,
S3,
C3.
Classic. I haven't tried it on. This is a C6. Warning to folks that the C6 and the H2 are probably gonna have partition changes because the BLE stack is like a lot of code, and so we're gonna have to twiddle some things so that we have enough space to enable it more boards.
Yeah.
So just keep a heads up for that with 9.1.
All right, and for folks who want to know more, stop by and see Scott this Friday.
2 p.m. Pacific here on Adafruit Streams. We'll talk about this and probably this.
Deep dive with Scott.
Deep dive.
Okay,
all right,
great.
thanks, Scott.
Thanks, Scott.
Thanks for having me.
All righty, let's go to Jeff. How's it going, Jeff?
Hello. So I've been spending the last couple of weeks working on something that community members have asked for. I'm going to try and lift this up into the camera, but yeah, hold on. No, I'm not going to do that. I'm gonna just tell you about it. Actually, I'll make you hear it. So we're doing MP3 playback on the ESP32S3 with CircuitPython. That's the short version.
Yay!
So on screen here,
you can,
in my pile of wires, I've got a ESP32 Feather TFT and the Max 9 something I2S amplifier, and it's playing a 48 kilobits per second, 22,000 hertz MP3 file out of speaker. And there's a pull request open. It's really exciting because I was really struggling with this for a little while. And Scott came along with the final clue today, got me back on the road, and this is the result. So,
okay.
All right, so this means folks can make their own MP3 players.
This means, coming up once we merge this,
JetPlayer.
you'll be
Well,
you'll
also
be able
things
to
triggers,
like
all the costuming, everything. Yeah.
And of course you'll have the Wi-Fi. Well, I haven't tested it with Wi-Fi running, but in principle, you'll have the Wi-Fi features available too. So you could like download an MP3 file to the SD card and then play it from the SD card. And that would
This is actually, I'll tell you why this is a little exciting to me, because I really want to update and revise the audio effects trigger board that we have with the VS1000, because it's like this ancient chip. I literally use all but 3 bytes of flash. It's like, I don't know how much. I think it's 4 megabytes or whatever, like the amount of flash. It's like I didn't have enough space to like change like the
sign your name.
Drive. You know what I mean? It was like, okay, I have only 8 bytes, and it's a little flaky, and people want more functionality. And I'm like, well, it's actually hard to find a chip that has native USB, is fairly inexpensive, and can do USB playback. It has native USB, so you can do mass storage, can do audio playback at a good rate, and I want to be able to do audio mixing. And I think like the SAMD51 probably could have done it, but to be honest, it was kind of expensive. Like I wanted to try to keep the same price. Whereas I think the S3
hard to do Wi-Fi too.
Well, I think the Wi-Fi is an interesting addition. And has really good I2S support, and I think that's kind of important if people want to have audio output that's really good quality. So I think it'd be really neat. Maybe I can revise that board to use an S3 mini module. That would be really nice.
That would be interesting. We'll check out kind of what the limits of it are, but I was kind of profiling on my scope. This was your suggestion to set a pin high when you start doing something and low when you finish. And so I could see that it's taking about 5% of the 1 core of CPU to decode the MP3 and then send it to the DMA peripheral. And that's again at that 48 kilobits per second MP3 rate. So I think we may be able to do stuff like mix MP3s, but we'll have to test that out and see kind of what the limits are.
Yeah.
Yeah.
The other cool thing is, people will convert files as needed. Like there's a WAV file format, and like we've been doing audio for a while with Circuit Python. It's been really easy for people to put audio in their project. It doesn't make it even easier. So good work, Jeff.
All right, see you around.
All right, thanks.
Alrighty. Okay, next, Melissa, what you got going on?
Hi, I have a CNC I've been working on here. I've actually made a version 1 a couple of years ago in a PC case, but I've kind of redone the whole thing. I actually ended up using DIN rail for a lot of the stuff.
That's cool.
And I've custom designed and 3D printed a lot of the parts on here. So like the mounts for these, I actually found on printables, but I've like made the mount for the main board. It's it runs like Verbal HAL, and it has a Teensy 4.1 for the main controller here. I've taken as much of the old parts as I can to reuse them on this. This uses some DIN rail mountable power supplies here, which is really helpful. And I really like the layout of this much better. I've gotten these little wire channel things here to kind of neaten up everything, so it looks pretty good here. And then on the front, for instance,
That's nice.
and then like designed this so mount here with power button and a little thing, so you could actually pull this out to look at it if you want, just like on the front of the VFD. And then I also have like a couple extra ports on there.
Nice build.
Thanks.
Cool.
It's good.
All right, we'll come back after it's all finished and maybe show it off.
Yeah, cut something out.
Yeah, or you'll be hosting until one of these weeks. So
Yeah.
you can you're hosting show until one of these weeks coming up, so maybe you can show it off then.
Yeah.
I love people who make like little wooden nameplates with their CNCs. It's just it's such a cute, homey thing.
All righty. Thanks so much, Melissa.
Okay.
Next up, we're going to go Noe, and then John Park, and then Seth, and then nanographics. We're going to get everyone in the next 10 minutes.
Yeah.
Noe, what you got going on?
Hey, folks. This week, I got a 3D printed prop using the Feather Prop Maker RP2040. So this has an LED noodle, and we have an OLED display that has the audio files listed on there, so you can kind of cycle through them using the little knob here. These two are connected with Stemma QT, so it was really easy to put those together.
Yeah.
I got the battery inside of the handle, and of course the LED noodle fitted here. It's a CircuitPython project. Shout out to Liz for putting together the code for this one. So you can change up the different sound effects and use the button here that's in the trigger to, well, play the sound effect.
I love how easy it is to make props now. You're like, oh, it's just plug and play and a couple, like very little soldering, not a lot of wiring.
Yeah, and the assembly is a lot easier these days. A lot of the times with like a Feather and a prop maker wing, you would have to kind of solder directly to the pins.
Yeah.
But this way, I can kind of wire up the things, thread them through, and then just screw block terminal. Fit them in. The speaker is fitted right here, so it's a good spot for the speaker. And having that built-in amplifier is really, really nice. Down here, you have access to the USB-C port, so you can always recharge the battery. And everything kind of snap fits. There's a couple screws here and there, but relatively pretty easy to put together. This is a piece of acrylic. I used my little baby CNC mill to cut this, but folks can 3D print that or laser cut it if they have access to one. And what I really like about this piece here, this is just a piece of plastic. It's one of those store-bought Christmas ornaments. So I thought it was a really good use of it.
No, it's great.
These LED noodles are really nice. I've always wanted to kind of do like a
it looks like a filament. It just looks super pro. Yeah,
it looks really nice. And you know, filaments these days are nice and shiny and glittery. So I didn't do any post-processing. It's just the different colored parts. It's kind of supposed to have this kind of steampunk aesthetic. And I also like mixing vinyl cut things. So the handle, you can kind of see there's a little bit of
nice.
Yeah, so that's just an SVG file that folks can cut or print it out. And I kind of like the kind of combination of acrylic, some injection molded plastic, and of course your 3D printed parts.
Yeah.
But yeah, it's pretty easy to put together. We got the Learn Guide published today, and there's a little video to go with it too. If you folks want to show
we'll
it.
be playing it on the show
Nice.
tonight.
Okay.
All right, thanks so much.
Yeah, no problem. Thanks.
And thanks, Liz, for writing that code.
All right, JP, what you got going on?
Hey, I've got this going on, a humongous arcade joystick.
Oh my God, that's so big.
This is this big thing from the golden age of MAME cabinets and people starting to play emulated games on their PCs. There were companies who made these giant things, and they use pretty standard arcade buttons and joysticks. This one also happens to have a trackball in there. And it was meant for PS2 and joystick ports, so there wasn't really a way to use it on a modern computer or game console. So I was able to take a little $4 Raspberry Pi Pico and use our little screw terminal Pi cowbell with
inspired by the wing shield.
Oh, yay! Yeah, it's a spiritual descendant of that. Makes wiring a lot easier. And some little there's fairly standard connectors with these things. This one happened to use JST-XH 5-pin connectors. And so you can see now I've got my Pico right there, and I have a USB panel mount port there that I plug in a little micro USB cable to. And the firmware this is running, which is GP2040, can be configured to act like a Switch controller, a PlayStation controller, an Xbox controller, a direct input, X input. So you can kind of use it on a lot of your different systems. So my son's coming home for the summer from college, and he's planning on whipping me in some Street Fighter and other fight games. So my plan is actually to put a second one in, so that the left side and the right side are just two separate USB controllers, which is the neatest way to deal with that. And then we'll be able to
also that way there's no like, oh, your key interfered with my key. It's like, no, there's two separate keys.
Totally separate. Yeah. So this is actually a zero solder, no cutting necessary. Even everything just kind of fit and worked. Easy to do. I screwed this into place where the old controller board that I pulled out that had like the PS2 thingies and stuff coming off of it went.
Well, it's good. Also, like the Pico has a lot of ground pins, so it's like, you know.
Yeah, it does. Yeah. I didn't have to double up anything. It's nice. And also one of the things that made my life a lot easier was the silk screen that you put on the back of this makes it a lot easier to know what pins you're plugging into, including all the ground pins have these white.
Yeah, so the Pico over, you know, it's like, oh no, what do you pull it out, look in the back? It's
So that was easy because you can just kind of look, insert wires, screw them down into place, and you get a nice result. So very happy with that. And that's my project build this week. And now moving on to some cool new stuff for workshop show tomorrow. So
all right, tune in tomorrow for JP's workshop.
All right, thanks, JP.
All right, next up, we're going to go to Seth.
Hey, Seth. Good to see you again.
Yeah.
Hey. So I've been making a little bit of progress since the last time I was on. I've been drawing a lot of inspiration from you guys, as always. And so I was thinking of ways that people can learn stuff easily and sort of see nice visual results. And so if you remember, I showed off a little FPGA board, and I've made some fixes to it. And I've actually now finally got it up for sale for people to learn with. But so you guys shipped like a rainbow chase sort of NeoPixel animation on a lot of the boards that you guys sent.
Yeah, it's usually it was programmed, basically.
Yeah. So I was like, I kind of want to go a similar path. So, and have a way to show that, you can learn how to do stuff like that with analog RGB. So I created a little thing so it'll cycle through the different colors and do a little bit of pulse width modulation from the FPGA right to the RGB LED there. Kind of give like a nice, when you first turn it on, you're like, oh wow, that's really pretty. And then another thing I wanted to show, so I've been working on this here too. So it's a little R piano. So it's a little touch controlled little electronic piano. So it's got a little speaker on the back, powered by the RP2040. And I've been trying out this I2S chip or mono amp that Nuvoton has actually came out with, I guess, not too long ago. It's new to me anyway. And so I thought it was pretty cool, and I wanted to put it on to a little board. And so right now it's just running Circuit Python, so we can sort of play some different tones. So like, I don't know if you can hear that, but So it plays the initial octave, so I think it's about 260 hertz for like middle C, and then there's little buttons where you can go up and down octaves. So
oh yeah, I can hear little beeps and boops.
So still a little bit of work to do on it, but another thing that I'm working on to try to add some more fun stuff to CircuitPython, and yeah, so it's made it really easy to test out, and yeah.
Nice.
Good stuff. Keep coming back with updates and more.
Yeah, definitely will do. Thanks, guys.
All right, thanks, Seth.
All right, thanks, Seth.
All right, Nanographs, you got 5 minutes. Play us out.
Shrink us out.
Everyone. So we're back here. We're hiding in the corner of the Portland State University microscope cave behind this microscope here.
Yep, where we were just attempting to mill an Adafruit logo. And we're gonna see if that worked. We got a little impatient and kind of stopped in the middle of this pattern. So it might be half of an Adafruit logo.
Can you all hear us okay?
Yeah, we can hear you. Yeah, we're just like amazed. It takes a second because we're like, okay, now
I just love how tiny you are compared to the machinery.
Now we're in the scene in Tron before you get put on the game grid.
I know.
Yeah, right. Let's see here.
Okay,
so we got that. I don't know what beam this is going to turn on, so we're about to find out.
Okay.
So we'll start a live scan. No? We've got...
Are we screen sharing?
Okay, we have signal.
Okay, ion beam is not going to work, so we're going to switch to the electron beam.
There's the Adafruit logo.
It's buried in there somewhere.
Okay,
so let's turn off the ion beam. Let's bring up the electron beam.
Is it going to be in the same place?
No, it's not going to be in the same place. We're going to do a little bit of navigating here. So we're going to go to external. There we go. We got a picture.
Okay.
So this is a dual beam. So it has a SEM beam and an electron beam on the same microscope. So we are working on doing a better job of switching between those two. So we'll zoom out here.
The goal is to find the tiny Adafruit logo that we have just did there.
So the backstory behind this microscope is that this one is a rather special microscope, we'll say. It was originally a prototype that was in the manufacturer's basement before it got moved here to the university. It was completely torn apart. It's built out of multiple different microscopes. It kind of works. There is a lot of tune-up that is happening still. One of the things that needs to be tuned up is the electron beam and the ion beam need to be adjusted so that they point at the same spot. And so because they don't point at the same spot, currently, there's several millimeters off. It takes a little bit of effort to figure out where was the beam pointing? Where is the beam pointing now? Where is my picture?
I know you can find it. I believe in you.
So let's make our picture a little bit brighter here. Okay, so now we're going to be... Okay, so let's see here. If the ion beam is off to the right, then... Okay. I'm taking a wild guess here.
Just strolling along.
Yeah, so we when we were milling the pattern, we just had enough time to just kind of start milling, and we didn't realize how long it was going to be, so we spent kind of most of the time before show and tell just like waiting as long as possible for the pattern to mill.
Yeah.
And so now we're doing a little bit of searching here.
Yeah. So you see that
there's
edge?
the center. Okay, so that. Okay. So the ion beam would have been off to the right side, maybe. Is that on top of something?
Oh, okay. That like crackly surface. You see the edge there?
Yeah, is that it?
It's like a Google Maps flyover.
Yep.
What could go wrong? Yeah, I was hoping the ion beam was going to be selected for this imaging, but it wasn't, so...
Well, if you can't figure it out, don't worry. Just come back next week. No biggie.
So this is our first time installing on a dual beam like this. And dual beams, it's twice the number of beams, but it's significantly more than twice the complexity.
And what are all those little chippies?
That's the shrapnel from the carving, right?
Yeah, sure. Yeah, no, I actually don't know what this is that's covering this whole sample. It's kind of weird.
Yeah.
Well.
Also got low battery on your laptop just to add to the pressure.
What could possibly go wrong?
Well, here's the thing. It's totally not a big deal. Don't worry about it.
Yeah, we'll post this in the Discord chat.
Yeah.
Somewhere on here, there is a 20 micron wide Adafruit
You're gonna find it like 10 seconds.
It's always the last place you look for. All right, we'll come back next week if you want to see this logo, and also be careful. Don't get hit by gamma rays and turn into home and stuff like that.
Yeah. True. I mean, it's just cool to look at like your Python script, open hardware control. This
frame. Yeah.
All righty. Well, we're gonna bounce out for Ask an Engineer, so you come back next week. Yeah.
We believe you. It's all good.
All right. Thanks so much, everybody. That is our show and tell from the big to the small. We'll see everybody next week. Thanks for making this the best half an hour of the week every single week. Ask an Engineer starts in like 1 minute. Bye.